Good morning. Today I am going to explain the topic electrical machines. So, in electrical machines, DC machines is the first topic. Okay, what is DC machines? So, DC machines are electromechanical energy. See the name electromechanical. Two energies are there, right? What are the energies? Electrical energy and mechanical energy. So electrical energy, it indicates that we can say simply electricity. Okay, mechanical energy, that's the physical energy. Okay, so as we convert electrical energy into mechanical energy or mechanical energy into electrical energy. Okay, this is what DC machine. Then principle. Actually, this DC machine works on the principle if the conductor moves in a magnetic field, an EMF is induced. What is EMF? Electromagnetic force. That is the generator action. Okay. So when the current flows in a magnetic field, a force is produced. That is what? Motor action. So we can say in DC machine, motor as well as generator both will be, the construction is same, the operation only differ, but it is based on the principle of electromagnetic principles. Okay, if it is DC generator, it's based on Faraday's law of electromagnetic induction. That is, when the conductor cuts the magnetic flux, an EMF is induced. If it is DC motor, it will be based on Lorentz force. What is that Lorentz force? It is one of the force. When this force experienced the conductor, when the current carrying conductor is placed in a magnetic field, it experiences the force. Okay, that is the principle. Then next we see about the construction. As I told earlier, this DC machine, that is generator or motor, both will be, the construction is same but the operation is different, right? So here the electromechanical energy conversion device that can work either DC generator or DC motor. Okay, so for DC generator, the mechanical energy is converted into electrical energy, but in DC motor, this electrical energy is converted into mechanical energy. But how to construct this DC machines? I told both construction is same, right? So what are the main parts used in this DC machine? Stator and the another one is rotor. Okay, so first we see about that stator. What is stator? From the name you understand, it's the stationary part. It does not move here and there. Okay, it will be stationary, it will constant. Okay, so what are the stator parts present in DC machine? Yoke, pole shoe and core, and the third one is field winding. Okay, yoke, second one pole shoe and core, next field winding. Next we see the each and every one we will explain that. Okay, the first one is next one, rotor. What is that rotor? It is the rotating part, right? Rotating part means it is not constant, it will movable. Okay, so what are the rotating part present in that DC machine? Armature core, armature winding, commutator, brushes, shaft. Okay, what are the rotating part? Armature core, armature winding, commutator, brushes and shaft. Okay, so next we see one by one. See, this is the diagrammatic representation of what DC machine. Okay, so the first one is yoke. What is yoke? Actually, it is the outer frame. See the diagram? That's the outer frame of this diagram. Okay, yoke. What is the purpose of this yoke? It provides protection. Where it gives the protection? To the rotating part. Okay, so some other protection it needs. So this yoke provides protection from moisture, dust and mechanical damage also. Okay, it also provides some mechanical support for the poles. Actually, this yolk is a iron body. Okay, why it is iron body? Because it have lower reluctance path. Okay, now this yolk is very essential because to complete the magnetic circuit. Okay, so what are the materials used in this yolk? It may be a cast iron, silicon steel, rolled steel and cast steel. Okay, this main purpose is to provide the mechanical support for the poles. If we use small DC machines, this yoke are made of cast iron, but but it is used for larger machines. The yoke may be the cast steel or rolled steel. Okay, this is about yoke. This is the structure. See the structure. The outer frame is yoke. Okay, we can say it's the frame of the machine. And what is the main purpose? To protect the rotation. Okay, as well as from it protect from moisture, dust, mechanical damage, etc. Okay, now the next one is what? Pole shoe. Okay, so the next one is pole shoe. See the structure of pole shoe here. What are the parts present here? Field winding, then pole shoe, pole, right? Then what is the purpose of this pole shoe? Why we are used to this poles? Because if we used poles, it produce the magnetic flux. When it produce magnetic flux, if the field winding is excited by DC supply voltage, not for AC supply, DC supply. Okay, while applying DC supply, the magnetic flux is produced. Okay, actually a pole of DC machine is a supporting structure. Okay, the field winding is wound over the poles. This pole shoe is an extended part. Did you see the shower? Right. Okay, so its appearances look like that only. Okay, due to its typical shape, it enlarges the area of the pole. Due to this enlarged area, more flux can spread and pass through air gap to the armature core and armature winding. Okay, this pole or pole shoe also have low reluctance path. Okay, so what are the materials used to this pole or pole shoe or pole core? Cast steel or cast iron. Okay, so this is about poles, pole shoe and pole core. Okay, now next see about that field winding. What is field winding? So winding means it's the wire which is wounded on the conductor. Okay, so if the magnetic field is present, we can say that is a field winding. The coils wound around the pole core. Okay, that is one field coil. Since this is not shunt connection or parallel connection, if it is series combination of field coil with each other, it will form the field winding. Okay, what is the other name of field winding? That is exciting winding, because it produces the flux. No, that's why. What are the materials used for field conductor or field winding? Enameled copper. Okay, now next one is what? Armature core. What is armature core? You all know what is core. Core is the inner part of the material, right? This armature core includes huge number of slots. Where the slots are present, its edge. Okay, the armature conductor is located in these slots only. Okay, this also provides lower reluctance path towards the flux which is generated with field winding. Okay, what are the materials used here? Whatever material may have the permeability having low reluctance. Okay, so we can use that materials. It may be iron or cast. Okay, so what about the lamination? If we are used to lamination, it's decrease the loss. Okay, because of eddy current. This eddy current means, what is that? Eddy current. What is eddy current? So eddy current is simply, we remember that eddy current is a circulating current. Okay, which induced in a conducting material when it when it exposed to the changing magnetic field. This eddy current flow in only closed path or closed loop, not for open loop. Okay, so This is what eddy current. So simply you remember eddy currents are the circulating currents. Okay, here we are used wire no wounding no. So wounding that the wires are circular in shape. Okay, so we can easily remember what type of current is flow through this wire wounded material, that is eddy current. Okay, then next one is what armature winding. Okay, what is that armature winding, how it formed? This armature winding can be formed by interconnecting the armature connector. Interconnecting means what? It will connected each and every one. Okay, whenever an armature winding is turned with help of prime mover, okay, then the voltage as well as magnetic flux gets induced within it. Okay, this winding is arranged to an exterior circuit. So what are the materials used this armature winding? Maybe copper. Okay, then commutator and brushes. So the main purpose of commutator is to collect the current, where it collect from armature conductor. Okay, and it will supply the current to the load. How it supply the current to load? Using brushes. Okay, so it provide unidirectional torque for DC motor. Unidirectional, what's the meaning of unidirectional? That is the flow of current from only one direction. Okay, what is torque? Torque is it's the force for rotating, rotational force, we can say rotational force. Okay, so this commutator can be built with a huge number of segments in the edge form of hard drawn copper. Okay, this the segments in the commutator are protected from the thin mica layer. Okay, then brushes indicates that it gather the current from commutator and supply to the load. Okay, this brushes wear with time to inspect the frequently. Okay, it will frequently we will check that we will check how the current will be gathered and given to the load. So what are the materials used in brushes? Graphite. Okay, so otherwise carbon, which is in the rectangular form. Okay, next shaft. What is shaft? It's also one of the DC machine, right? It's a rotating cylindrical member mounted at the center of the machine. Okay, it carries. So what are the main things carried this shaft? Because this is a rotating cylindrical part, no? Which one carries? Armature core, commutator and other rotating parts. Okay, what is the main purpose of shaft? It supports the armature core and winding, and it holds the commutator in position. Okay, so it will not move here and there. Okay, this if you are used to shaft, it placed this or it keep the commutator in the position. Okay, so it transmit the mechanical power. If it is generator, from prime mover to armature. If you are used motor, from armature to load. Okay, it ensure we can give the surety because it give the smooth rotation inside the bearings. Okay, so if you are used mild steel or alloy steel as a shaft, we will get the high strength and good rigidity. Okay, then it have the ability to withstand torsion and bending. Okay, next we see about that. So in shaft so many stresses are there: torsional stress, bending stress, etc. Okay, so torsional stress means due to torque transmission. If it is bending stress, due to weight of armature and component. Right, what are the mounting parts on shaft? Armature core, commutator, fan, etc. Armature core, it's the main part which is present inside. Commutator for current conversion. For fan, that is for cooling purpose, you know already. In our day to day life we used to fan. No, what is the purpose of fan? We are used for cooling only. Okay, now we can simply say that shaft is the backbone of the rotating material. Okay, and it connects the mechanical as well as the electrical parts. It must be strong, rigid and well balanced on. Okay, then next one, types of DC machine. Okay, what are the main types of DC machine? Separate excitation as well as self excitation. In a separate excitation type, the field coils are activated with separate DC source. Okay, not for common DC source. Whatever machine we are used, all the machines have separate DC source. If it is self-excitation type of DC machine means the flow of current throughout the field winding it's supplied to the machine. Okay, so actually this DC machines are classified into four types. What are the types? Separately excited DC machine, shunt wound or shunt machine, series wound series machine. Okay, then compound wound compound machine. Okay, first one, separately excited DC machine. Separately excited DC machine, what is that? From the name itself we can easily understand that a separate DC source is utilized. For what purpose? For activating the field coil. In order to activate the field coil we need the separate source, not for common source. Okay, next one, shunt wound or shunt machine, right? Shunt indicates parallel connection. Okay, so the field coil and the field coils are arranged in parallel form through the armature. Okay, if the shunt field gets the complete output voltage of generator or otherwise a motor supply voltage, it's normally made of a huge number of twist wire with small field current carry. Okay, next one is series wind. What is that series wind DC machine? The field coils are allied in series or arranged in series. Okay, so shunt wound arranged in parallel, here arranged in series through the armature. As the series field winding gets the armature current as well as the armature current is huge, due to this the series field winding includes few twists of wire of big cross sectional region. Okay, then the next one is compound wound. What is compound wound? It includes both series as well as shunt. Okay, so there we studied separately, here we are used to both characteristics in a single wound. Okay, the two windings are carried out with every machine pole. Okay, this machines include that few twists of huge cross sectional region as well as shunt windings. It includes several fine twist wire twist. Okay, then the connection of the compound machine can be done in two ways. What are the shunt field is arranged in parallel by the armature only, then the machine can be named as short shunt compound machine. If the shunt field is allied in parallel by both the armature as well as series field, then the machine is named as long shunt compound machine. Actually, two machines are there, short shunt compound machine and long shunt compound machine. Short shunt compound machine, it's why this name comes like this? If the shunt field is arranged in parallel by the armature, we can say short shunt. Okay, long shunt means the shunt field is arranged in parallel by both the armature as well as series field, then we can say that as long shunt. Okay, next we see the EMF equation. What are the parameters used to find the EMF in DC machine? Flux pi, we indicate phi as the flux. For every pole, how to measure flux? The unit is Weber, right? Next parameter we are used to this EMF equation is P. What is P? How many number of poles we are used here? Okay, that is what poles. Then Z is the total number of conductor within the armature. N is the rotation speed for an armature in the revolution for each second. For each second, how much speed rotation, how much it is rotated. Okay, what is A? A is the number of parallel lane throughout the armature among the opposite polarity brushes. Z by A, it indicates number of armature conductor within series for each parallel lane. Okay, so see the equation. This is the first equation is the standard value and the final answer is the EMF equation. Okay, this is the EMF equation of DC machine. It's common for both. Then next we see about the AC and DC machine. Okay, difference between AC and DC machine. So first we see about that type of current. Which type of current we are used to this DC machine and AC machine? For DC machine, direct current. What about AC machine? Alternating current. Okay. The main principle of electromagnetic induction for both DC machine as well as AC machine. We are used, the principle is electromagnetic induction, but in a DC machine the construction have the difference is commutator brushes are used in DC machine, but in AC machine there is no brushes, there is no commutator. Okay, mostly brushes are used. Okay. Then maintenance, this in DC machine need high maintenance. Okay, but AC having low maintenance. While compared with cost, this DC is costly, AC is economically. Okay, what about the efficiency? So DC have lower efficiency and AC have higher efficiency. Okay, then its size and weight compared to AC and DC. DC is bulky, but AC is compact. Okay, then some what are the losses present in DC? More losses. Okay, but in AC only less losses. Then what are the applications used here? Cranes, lift, these are used in DC machine, and AC machine, fan pumps industries. Okay, then losses in DC machine. What are the losses present what are the losses in DC machine? Losses indicates that energy loss. Okay, that is if it have losses, it will affect the efficiency. Actually there are divided into three types. Okay, copper loss, core loss, then mechanical loss. Okay, so copper loss indicates that it occurs due to resistance of winding. Okay, these losses depend on current, but in core loss it occurs in armature core. Some of the types of core loss we can say it is otherwise called as iron losses. What are the core losses present in DC machine? Hysteresis loss, then eddy current loss. Mostly this loss depends on flux and speed. Hysteresis loss means based on hysteresis, that is repeated magnetization of core. Okay, eddy current loss, as we explained earlier, due to circulating current in core. Okay, then mechanical loss we can say due to moving parts. Okay, something related to friction loss or windage loss. Friction loss indicates bearings, brushes, etc. Windage loss means air resistance due to rotation. Okay, due to loss, what is the main process? Its efficiency will reduce. Okay, so here in DC machine, so the main purpose is the losses occurs, its efficiency will decrease. Okay, then advantages. What are the advantages of DC machine? Like DC motor have various advantages: starting torque high, reversing, fast starting and stopping, changeable speed through voltage input. Okay, these are very easily controlled, as well as cheaper when compared with AC. Speed control is good. Torque, that is force, rotating force, is high. Its operation is seamless, free from harmonics. Harmonics indicates a distortion. Okay, installation and maintenance is easy. Okay, these are about DC machines. Thank you.